Joel Stout's presentation on the plane power alternator, there is currently no way to install a plane power alternator on an engine-driven air conditioner system. The pulley from Aerostar will not mount. The shaft size is much different on the plane power. It's much smaller. So if you've misunderstood that like I did, there's still no way to replace the alternator associated with the right engine-driven air conditioning system. So, can you replace one of the alternators with the plane power? Yes, you can. They work just fine. Well, it seems like to me that many of the questions this morning have been about troubleshooting. And Alan Speakmaster is going to talk to us about troubleshooting the Aerostar. Come on up, Alan.
Good morning, everybody. So 59 years ago, when I started playing with airplanes, my dad said to me, "Son, I want you to do whatever you want to do to be happy." So I went back to bed. So I want you to know that while Joel was teaching you all about upgrades for the airplane to make it better, more efficient and safer, so you could fly further without things breaking, I want to show you a mod that we came up with to help you fly further and be more comfortable. This way you can do Joel's long distance trip and you won't break either. We've been trying to sell this thing for probably 15 years. Not one order yet. Okay. So Joel was talking about alternators. Here's the interesting thing. You're all pilots. So I've probably spent 36 years with you at different conventions teaching you the innards. I've cut props in half, I've cut governors in half, I've cut mags in half, I've taken a heater and cut it in half, and I've showed you the innards and said, this is how it all works. But I'm realizing for all these years, that's worthless. You don't care what's inside this stuff. You're not mechanics. Pilots are not mechanics, very few of them. Lots of mechanics are pilots, though. But the average pilot doesn't give a monkey's what's inside something. They just want to make sure it doesn't break, and if it breaks, what to do if it does break. So instead of standing here and saying to you, look guys, if your alternator belt breaks, it's a 37A19973-382, you don't care. I can say to you that the little micro switches in the yoke trim switch are a 1SXT. You don't care. You just want to know if it breaks, how do I fix it? Or how do I get it fixed? Or why did it break? Or what can I do to stop it breaking? So I decided this morning, let me try and talk to you from a pilot's perspective. What are you looking for to stop things breaking? What should you do if something does break? So here's a really classic thing. I'm going to bet, and I've come up with 8 different items. And I'm going to tell you now, alternators, nose wheel shimmy, broken steering collars, drooping nose gear doors, air pump failures, breaking landing gear bell cranks, strut disease, and broken turbo mounts. And if there's anyone here that says they haven't had one of these, you must have bought the airplane yesterday and you haven't flown yet. So let's pick the alternator system from the pilot side. You're flying along and you see this sign, and it's this is where it starts. So Joel, next picture. It's broken like the airplane. So the first thing that you do when you get a warning light, I'm assuming, is you look at the ammeter. If this is not the first thing you do, it should be the first thing you do. You're going to look at the ammeter and find out what does it say. So next picture, please. I want you all, did you all note that reading? 40 amps. Okay, see where the selector, the ammeter selector is? Okay, so the warning light was the left alternator failure. So you looked at the ammeter, in the middle position it said 40. You've moved the selector to the left and it says 0. Okay, next picture. And that says, so now excluding Don or Jimmy or Joe, I'm asking you guys, what are you going to do? What's the problem? So does everyone agree it's still working or it isn't? Or the left's failed? What's the situation? So you think it's working. Does everyone agree it's working? Left light is on. You've gone to the ammeter to the left and it says 0. So the light and the ammeter are both saying the same thing, that the left side is not working.
I think it's not working.
So you're the pilot, you're in the airplane with passengers, it's night IFR, and that light comes on. This is the pilot is now troubleshooting. I've given you all the information to know the answer. So question 1 is, the left light is on, the ammeter says 0. Is this real or is it not? Answers, pilots, answers. You think it's real. Everyone think it's real? Okay, how about, can we go back a picture? And back another picture. The total draw on the system is 40 amps. Let's go forward a picture again. And there's nothing showing on the meter for that side. No, I said there's nothing showing on the meter. Let's go to the next picture. It's 20. So my first question to you while you're flying along IMC at night with a plane full of passengers, where's the other 20 amps coming from? Okay, let's go to the last picture. What's the voltage? Can you get 28 volts from the battery? No. Okay, so we got the light on that says alternator failure. We got the left side that shows 0. The middle shows 40, the right shows 20, but the voltage is above battery. This whole thing is false. There's nothing wrong. It's all indication. It's really important for you all to think about this. If you've got 40 in the middle and 20 on one side, where's the other 20 coming from? It can't come from the battery. So this last pushing the button that shows the system voltage, it doesn't matter where the meter is selected, it's the same voltage it will read anywhere. So 27 and up is from a working alternator. It can't be from a battery. So you don't care that the light is on, you don't care the left ammeter is saying, quote, hey, the light on is confirming it's not working. It's false. If you've got 40 in the middle and 20 from somewhere, the other 20 is coming from the left alternator. So what are you going to do? Nothing. You're going to stick chewing gum on the light and ignore it. The last thing you're going to do is start switching alternators on and off, because now you will have a problem. Okay, next pictures. This probably catches more people out than anything else. People will phone up and say, my left alternator's not working, and my first question is, how do you know? Well, I don't get anything on the left ammeter. But what was it in the middle? X. What was it on the right? Well, why do you care? It's the left we're looking at. It's really important. You need to think about this. If you've got a reading in the middle, whatever it is, and half of that reading on the other side, it's got to be working. So your total operation at that point is nothing. So now the next set of pictures. We've got the same indication. Left side is not working. Center position is still 40. Left position is now 20. Right position is 20. What's wrong with it? What are you going to do? What are you going to turn off or on? What are you all going to do? Anyone think there's a problem? Okay, here we go again. I need you to understand this. You don't need to check the voltage. I'm showing you that the readings on the ammeter are all good. It's an indication problem. Why do you want to go pushing buttons to see what the voltage is? This is where you guys give yourself the biggest expense. To have a light turn on, 90% of the time it's a broken wire at the aux terminal on the alternator. Or it's the sensor switch in the back of the cabin. It's not an alternator failure. Doesn't matter what the light says. If you stop and think about this, you don't care how the system works. You don't care what's in the alternator or the diodes or anything else. All you know is you've proved by this amazing indication system that shows left, right, center, the voltage, you can troubleshoot it all and you don't have to give yourself a problem, which you can do. You start flicking switches. Invariably, the first thing that happens is someone turns that left switch off to try and recycle it. And when they turn it off, now the belt on the right side slips. Now suddenly you've got no alternators. It has happened so many times. So don't touch anything. No matter what it says as a failure mode, look at it and think about it for a minute. That's all. You save putting yourself in harm, you save expense, you save aggravation, and you're not sitting there thinking, oh my God, I got another failure and it only happened last week or 2 hours ago, which it may be. Any questions on any of that?
So if it shows all 40 being on the right,
if all the readings are on one side, now it's saying something is wrong with the other side. So if you've got 40 in the middle and 40 on either side, then the remaining side is not working. Can you go back to the descriptions? So back to the original descriptions, the list. So when Joel was telling you about the ammeter and the shunts, I don't know how many of you know what is right above the co-pilot's knee. Does anyone here know? There's a bunch of fuses. Does anyone have any idea what they are? This is really sad. These are pilot replaceable fuses. There are 6 vertical fuses with a couple of spares in front. There may be some extras that have been mounted in the field. But there is a panel, it is right above the co-pilot's knee, and it's mounted flat, and there are 6 push-in and turn fuses that work. So this is the fuse holder, and it is mounted above the co-pilot's knee, so when you look at it, that's the view. These 6 fuses are all for the ammeter. So if you get a reading on the ammeter that is 0, but you know the alternator's all working fine, the odds are either the fuse is blown or one of the wires is broken on the solder connection. So if you, Joel, if you go back to the original listing, Scroll down. Okay. Click that one. And the one to the left of it. Sorry. And I think there's one more to the left. No, sorry, come forward one more. So just like this unit, this is right above the co-pilot's knee. So you can check those fuses. And the odds are the ammeter's not working either because the fuse is blown or because the wire is broken on the back of the fuse holder. They're 1 amp fuses, and just like this panel, there are spare fuses here. It's really sad that these are all pilot replaceable fuses and none of you knew what this is. And it's in all your airplanes. It's right above the co-pilot's knee. Just bend down and look, and there they all are. What makes these fuses really interesting is that there's 2 fuses for each reading. One fuse does the current reading. The other fuse does the current and voltage. So a blown fuse can lose the voltage when you're selected to that ammeter if you push the button. And can we come back to the list? This one. It's weird the way they are. In the center area, the 3 oval shapes, is the fuses below your, above the co-pilot's knee. And as you're looking at the fuses, the uppermost ones are the right side of the fuselage, nearest to the sidewall. The bottom is nearest to the pedestal. And it's really funny how they use it. If you match the colors, the 2 on the upper side is for the right, is for the left alternator. The middle one and the bottom one, which would represent the left side, is for the battery reading, and the remaining 2 is for the other alternator, for the right side. You would think that Aerostar would have put them 2, 2, and 2, but they didn't. They're weird. Any questions about alternators, ammeter readings, what you see in flight? Nothing, okay. Yes? 1 amp fuses. They're fine wire fuses. And the reason they use fuses is if there's a short, it blows instantly. If you use a circuit breaker, there's a delay, and that can be too late, by which time the instrument can be trashed. So, no. We find that, and it's really weird, the 2 wires soldered to the back of each one of these terminals, I haven't yet worked out why, but the wire that is soldered on the side breaks about 10 times more often than the fuse blows. It's never the wire on the end, it's always a side one. And these wires have got insulating tubes around them. And the insulation holds the wire to the terminal, so when you look, you don't see it broken until you pull the wire. Any more questions on those systems? Yes? Yes. Yeah, so the statement basically is that after the fuses have been in there a long time, because the ends corrode and you pull the fuse out and the end caps just come off totally. Last thing is a brief thing on paralleling that Joel was going through. If you have alternators that have got 2 different size pulleys on them, you will never parallel them, because the smaller pulley turns much faster than the bigger pulley, so the outputs are different. The other thing is you can change two like Prestolite alternators, for instance, and when they test them on the test bench, there is a range of output for a specific RPM. So let's say that at 2000 RPM, the range is 30 to 35 amps output. This one can be at 30 and this one can be at 35. And when you try and parallel them, you can't. And the answer to that is, if you split the RPM when you're testing it, and you find that with a 200 RPM split, you can make them parallel over the whole range, it's either a different pulley, or it's a different ability of that specific alternator compared with the other one, and you're never going to fix it. So just ignore it. Anything else on those things? Yeah, and that's the only way of doing it. And as soon as you reduce that, so the statement is that he parallels them with a high load and makes them parallel. And as soon as you reduce the load, now you'll see the split come back in again. Nose wheel shimmy. Who's had nose wheel shimmy? And if I see no hands, I'm not going to believe you. Okay, the primary cause for nose wheel shimmy is play in the nose gear. There's only one real way of finding all of the nose wheel play. And that's you have to get the nose wheel off the ground to start with. What happens to the nose wheel when you take it off the ground? It extends, and what else happens? It centers on the cam. Ken says centering cam, which is right. So as soon as you take the nose off the ground, the nose wheel extends and it turns straight. Now you can't feel the play because it's locked in straight on a cam that's inside the strut. So what we found over 36 years is you have to get the nose wheel off the ground, dump the air pressure so you can partially collapse the strut to get it off the centering cam, and then jiggle it. If there's any play, your shop will find the play. Well, we do that, and we do it on the ground, and we do it with grease plates. But then when you jack it up and collapse the strut, you find out there's twice as much play as you realized. So if you've got nose wheel shimmy and your shop can't find it, the two things are play and air in the actuator. The second thing is, and this might surprise you, how many guys love Goodyear Flight Custom 3 tires? Does anyone even know what tires are on their airplanes? Do you have tires on your airplanes? Okay, the tire that most shops and customers go to is either a Goodyear Flight Custom 3, and on the nose it's a 606 ply, or they go with a Michelin. The interesting thing is it's a really heavy tire, and it's a square section tire, so when it's sitting on the ground, it's a square section. Sometimes it is impossible to get rid of nose wheel shimmy with a Goodyear Flight Custom 3 tire on the nose. It weighs 11 pounds. We found to fix this problem, we just put on a McCreary Airhawk 606 tire. It's half the price. It only weighs 7 pounds. The nose gear retracts faster on rotation, and the shimmy's gone. A McCreary Airhawk 606 6-ply. It's rated for the same loads as the Flight Custom 3, and it's half the price. McCreary Airhawk. It's a 606 size 6-ply. It's half the price of the Goodrich. It's a round section rather than square. Goodyear tires can be a pain in the neck on an Aerostar nose because of the angle of dangle of the nose wheel strut. It's just setting itself up for nose wheel shimmy. So any play and the shimmy will start. It will change depending on your fuel load, your passenger load. It can be there today and not there tomorrow. And you can fix all of the play and still have it. If you fix the play and use a McCreary tyre, you won't have nose wheel shimmy. It's a round section. We've never done that. We just change the dam, fix the blade, change the tyre, end of problem, permanently. So you put on a Goodyear tyre on the nose strut and you end up changing it because it's been on there so long it's perished. It gets cracks from perishing. You put a McCreary tyre on, you end up changing it because it's worn out, because it's a much softer tyre. But there's a 4.5 pounds difference in weight between the two. So as I say, so you select up and find your up light comes on much quicker than it did before. It still comes down as fast because air load is pushing it, but it retracts faster. Now when your up light doesn't come on, by the way, it doesn't mean it's the nose gear. Because if one of the switches on the main gear is not working or it's intermittent, the up light still doesn't come on. And the secret to that is there a delay before the light comes on? Usually if there's a delay in the up light, it means one of the uplock switches is dirty. Or it can be a nose or a main. Any questions on shimmy? Just standard. Okay, let's talk about the steering collar and the doors. How many people have had a steering collar break or broken? A couple. Okay. So there's two types of steering collar. There's an ozone collar and a Weeble collar. For those of you who don't know the difference, you can actually look at these two Aerostars here. This one here in the corner is a Weeble nose strut. And if you look at where the chrome tube goes up inside the strut, you'll see the lowermost collar is round and it's held on with 4 bolts. The ozone collar, which the one at the front has got, is like a castle that's screwed on and it's safety wired on. And the ozone ones were from aircraft like serial number 611 and on that came out in mid-79. So lower than that, you're ozone. Higher than that, you're probably a Weeble. Hand in hand with that, for parts that you should carry in the airplane, if you're a Weeble airplane like this, you should all carry in the back of the pilot seat a part number 450530-501. It's the shear pin for the nose gear doors. Sooner or later, you will need one. You should call Aerostar and order one of those pins and drop it in a bag in the back of the seat, because when you look at your nose doors and they're drooping, that's what you need. The 450-530-501 is the number. If you're smart, you'll carry a steering pin to go with that. And that's a 450-521-001. That's the pin between the steering actuator and the steering collar. If the ground handlers have been rough, that pin gets bent. Now you end up with nose wheel shimmy because the pin is bent. If you're an ozone nose gear like the front one, and your nose gear doors are drooping, you've got a problem. Because those airplanes didn't have a shear pin. The casting on the front of the strut is what works the door, and if the handlers have been rough and your doors are drooping, you've broken the front of the gear casting. So there's nothing you can do without getting it to an Aerostar shop where they have to take the nose gear out of the airplane to fix it. The steering pin on that airplane is an NAS bolt. So for anyone who's got one of those airplanes, that is an NAS 464P4-43 bolt. Or in an emergency, you can carry an AN 4-43 bolt. And if you're smart, for respective airplanes, you will all carry one of those 3 things 2 for the Weeble, 1 for that, so that you don't get stuck somewhere. The steering collar. This airplane here, you can just about mark out the remains of a black turn limit sign on the nose. Do you all see it on the left side? So now you land somewhere and the line people very nicely are going to park the airplane, and they come over in their big tug to move your airplane. They can't feel when your turn limits are reached. And if it's like this that they can't see it, they don't know when it's got to your turn limits. So they will bend the steering pin and they can break the steering collar. The 2 things you should all do, no matter which type airplane you've got, is when you land and you've parked the airplane, before you walk away, you should look at the steering collar to see if it's cracked or breaking. And when you come back before you fly, you should look at the steering collar, because if it's broken now, you know who did it and where you were when it happened, so someone else pays the bill. And the collar's like $2,500 a collar. Yes? Has a removable... Oh, okay. And that's a pretty smart idea. It's like... Yes, so the statement from Jimmy Mallin is that Sandy Thompson's got a removable P for the nose scissors. So that's an STC kit? Because it used to be on like Aztecs and Navajos, when you didn't want the nose gear housings to be broken in half, we'd pull the scissors out and it was fine, and put a clip in, and it was fine till the feds came along and went crazy. So what we do to try and stop these limits being exceeded, and you may want to do this for your own interest, it's really interesting. If you get a tow bar and put a hand tow bar on the nose, or one of the tow bars they use with a tug, and turn it to the full extremes both ways, you will not believe how hard it is to do that. It is really stiff to turn the nose wheel left and right. So then you'll understand why when they're doing it with a tug, they can't feel any of this. If they move too quick to change direction, breaks the collar or bends the shear pin. What we do is we put a tow bar on the airplane and we push the tow bar all the way to the limit, then we bring it back 12 inches, and that's where we put the turn limit sign. We never put the turn limit sign where the turn limit actually is, because they get there and think, I'll just go a smidget more and another 1,000 and it's broken. The other interesting thing is, does anyone know where the shimmy damper is on the Aerostar? The actuator is the shimmy damper, and the actuator is a steering actuator. And does anyone know how a shimmy damper works? So the shimmy damper is a cylinder with a plunger that moves backwards and forwards through the middle with a piston on it, and they drill a pinhole in the piston, so when the tube, the rod, moves backwards and forwards through the body, the oil squirts through the little hole from one side to the other side, and that's what dampens out the movement. In the Aerostar, you can't do that in the shimmy damper because you wouldn't be able to steer it. When you went to the steering operation, the fluid would go from one side to the other side and you'd have no steering operation. Can you come down? Yes.
It's also, that hole causes you to, the inertia of the light itself after turning left and turning right after a period of time. So you can't let go of the switch to turn it off. If you do, it'll break itself back out again.
While you're rolling.
While you're rolling.
Yeah, but that's because of the angular dangle of the nose gear. So how many people have had problems steering? Suddenly you can't steer left or right. You guys have the most amazing, airworthy, not broken Aerostars I've ever seen. No one's had this problem. When you operate your little split rocker switch, the top half of the switch tells the solenoid assembly whether the pilot wants to steer left or right. The bottom half, if you look at the very bottom of that, there's a solenoid. If you're going to make the airplane steer left, you have to push fluid into one side of the steering actuator. But you can't push it in if the fluid the other side can't get out somewhere. So when you push the bottom half of that split rocker, it does two things. It opens that lower solenoid to let the return fluid out, and it puts the ground on the left or right solenoids at the top. So now you can steer. Really, really, really frequently, probably 60% of the time when you operate the steering and it doesn't want to work in either direction, it means that solenoid on the very bottom is not opening. So the fluid's going in, but it can't get back out the other side of the steering actuator. So now the steering doesn't move. And the last thing that goes wrong is the contacts in the switch. So that's it for the steering. And this is what it's like with the nose gear skins removed. And while you're looking at it, when a shop tells you that your hat section is cracked, these are the hat sections under the radio floor, and there's a mirror image one in the nose gear bay. So that's the parts that they're referring to. And if you look at this area right above the back end, all of this reinforcement that is there is Christie's upgrade for the nose gear kit to reinforce that hat section so it doesn't keep breaking as it does. Okay, how about door seals, pressurized airplanes? How often does your door seal cycle? How many people have got a pressurized Aerostar? Okay, and your door seals never cycle? Okay. So, how many of you have Aerostar's electric door seal option kit? A lot of you. Anyone with a P model that doesn't have the electric door seal kit? Only 2 of you. And your door seal doesn't cycle? How often does it cycle? Okay. So if you have a leak in the door seal system, then you're a pressurized Aerostar, and you don't have the electric option, every time that door seal cycles, it takes the wing regulator valves, which are in one of these pictures. This is a wing regulator valve, and usually it's dumping the extra pressure over 5 psi overboard. And it dumps it out through that louvered panel between the engine and the fuselage underneath. Every time your door seal cycles on the manual system, that valve closes. And now the pressure being backed up against your engine air pumps raises high. And if the door seal keeps cycling, it will take out the air pump. So it's easier to fix the leak so the door seal doesn't cycle, to save the cost of the air pump. And if they're the big pumps, the 441cc17s, they're like $1,000 each. If you have the Aerostar electric kit and you select it to the electric option, there is a pump in the back of the airplane on the firewall, which is in one of these pictures, which can sit and cycle all day long.
Is this it?
No, that's the door seal valve. Either way. It's an electric pump, sits mounted to the 176 panel, facing backwards, it's to the right of centre. And the electric pump can run all day long, and it doesn't matter if the door seal's leaking or not, and it won't harm anything else, and the pump is able to run non-stop all day long. So even if the door seal's leaking. If you don't want to lose your door seal, don't let anyone touch the door handle except you. A lot of the airplanes, when you turn the door handle around and it springs back to its neutral open position, the pins don't fully retract. And now when the door opens or closes, a protruding pin rubs against the edge of the seal, and now it tears your seal. And there's only one place you can buy these seals now, and that's the flight shop, an STC kit. You can't buy it from Aerostar, the company stopped making it for them. If you don't want to lose the door seal, open and close the door yourself, and it sounds crazy, but when you open that door, you turn the handle as far as it goes to the open position before you move the door. Or you tell the radio shop, whoever's going to work on the airplane, to do the same thing, so that you don't lose a door seal because of them, because it's an expensive part. How about gear bell cranks? Who's lost a gear bell crank? Well, a lot of people, really. So when you operate the gear, the gear limit speed is 156 knots, but more importantly is, where is the ball in the turn and bank instrument? If that ball is not centered when you operate the gear, because if the airplane is now not flying straight, the loading around the gear clamshell doors, which are these giant doors that open and snap shut, the loading is strained on whichever side that is, and it will break the bell crank. You won't necessarily know about it, because if it breaks at the wrong time, now the gear comes up and the gear is jammed against the underneath of the door, and you're now thinking, why am I flying so slow? And you can't get into the co-pilot seat and put your face against the window to see where it is on the right-hand side. A good option to stick mirrors on the inside of the nacelle. Of course, now you can see if the clamshells are closed. You can all see the nose gear, most of you, from the spinner, but you can't see the mains. You can see if they're down, but you can't see if they're up. So you need to make sure that ball is always in the middle before you operate the gear. It's much cheaper than changing the bell cranks. Yes, it gets more expensive. So Don is relating the braking period and where is the gear door when you land. Aerostar's a really interesting gear door system. The hydraulic pressure operates an actuator, and all that does is pulls the gear door tight. There is a mechanical push rod linkage that actually does the opening and closing, but the actuator is what pulls the door tight at the end. And when the gear door breaks, that actuator's not doing anything with the door. So now mechanically the linkage pushes the gear door, but there's nothing to help it close, so now it's hanging down. Struts. Sandy loves this. Who's got Aerostar disease? Right, you guys got airplanes that are just beyond perfect. This is awesome. So Sandy, of course, has got this kit to fix the Aerostar strut disease. And the Aerostar struts is not just a chrome tube that goes up and down inside a housing. Inside the chrome tube, there's another part. It's a floating piston. And if the piston sticks inside the tube, then the gear doesn't operate as it should. So now you end up with this disease. So if a scissor is tight, or the strut is binding, or that piston inside that you can't get to without taking the strut apart, if that sticks, Aerostar disease. Sandy came up with this kit using a Teflon type material on all of the stuff involved in that. The airplane's always like this.
It doesn't totally stop it out.
But big difference, big difference. Any questions on struts? Yeah, and it's like, is it like 400 psi in both of them? Okay, P models. Who's broken a turbo mount? Only 4 people amongst all these P models have broken turbo mounts. Boy, this, Joel, agree with me. This takes some believing, right? Hey, very good, I like that.
Homer, shut up.
Broken turbo mounts, so there's the old version and the new version. So when Aerostar came out with their new version of these Inconel type material mounts, the first ones broke like a piece of glass. You tapped them and they just shattered. And they've gradually improved them, but they still break like the old ones. The one big benefit of the new mount kits is they're adjustable, so it's easier to put the turbo where you want it to mate up with the wastegate and the wastegate pipe and the mounting flanges. But they still break just like the old ones. For your safety, when you pre-flight, you should all grab that tailpipe and wiggle that sucker up and down. It should not move at all. It may move left and right, which is the linkage bending. It shouldn't move up and down, and you all should be doing that every flight. And if it moves up and down, don't fly. Many years ago, I think this was probably in whenever the Washington DC meeting was, I'm guessing this was maybe 88. So someone said to me, quote, "Did you want to be on the maintenance panel?" And I said, "Sure, Aerostar was an Aerostar." And someone said, "So if I was doing a long trip in my Aerostar, what should I carry for an emergency package?" And I said, I would carry a plain screwdriver, a Phillips screwdriver, and membership for the Hilton Honors Club. I've now modified that. You still need a plain screwdriver and a Phillips screwdriver. Number 3 is a clean shirt. Now number 4 is a Marriott membership because their points are better. Let's bounce about for a minute. A big conversation about fuel quantity systems and changing pins and cleaning pins. There is an aerosol out there, it's called Pro Gold XL. Sounds crazy, but you can buy it in a music shop. It's a contact enhancer. So if you get this little aerosol can, then you take the cannon plug off the bottom of the computer, which is a quarter turn, and it drops, and you pull it down. Spray all the pins with this stuff. Shake it out, put it back on. End of pin connection problem. There is one area that will drive people nuts with a wing fuel quantity reading that you put the master switch on and the needle dives down. Not up, down. The Aerostar fuel system is a fuel capacitance measuring system. It's measuring capacitance of the flow of the units. So when you take a wing unit out, you're looking at 2 gold analyzed tubes, one inside the other, or it may be 3, one inside the other. And that's the whole workings of a fuel unit. Do you have one, Joel? The wires that come to it come out from the computer. When the unit is submerged in the wing, it's operating as a condenser. And as the fuel goes up and down these tubes, the capacitance between the tubes is being measured by the computer. So it's measuring capacitance. Yes, perfect. Yes, please. So this is what it looks like. And it just sits in a pair of clips on these white nylon holdings. And that's it. Just sits there and doesn't move. And there are tubes that are inside. I'll pass it around so you can see. So when it's in there, the fuel comes up and down as it gets used. And the computer is measuring the capacitance across these tubes. It is really, really sensitive. So for those of you that have an electric meter and feel inclined to troubleshoot, which is probably not many of you, In the wiring diagram, it shows these wires as being a high Z and a low Z wire and the ground. And if you put the meter on the lowest reading of ohms, there shouldn't be any connection across any of the pins in any direction or from any of the pins to ground. And really, really, really frequently, as crazy as this sounds, inside this plug on the end of this wire in the wing, the separator between the pins is a rubber block with the holes, and so the pins push through this rubber block. So when you put it on and tighten it, fuel doesn't leak out because the rubber block squeezes on the pins and the plugs, makes it fuel tight. What happens over time is the rubber conducts. So now the computer's getting a reading from the pins through the rubber. And you will go crazy trying to find this. And we found the answer was, if you go in the wing, when we're in the wing, and we realize we've got this funky reading and we've taken this out and we've measured all the wires and checked the connections here and everything looks good, you put it back in and you tighten the plug and there's the fault, and you loosen the plug and the fault's gone away. And we realized it's the resistance being read through the rubber. So you can change the pins and you can cut the wires and you can change this part on the end and you put it back together and you still got the same problem. The rubber in the end. Sounds crazy, but you can go crazy finding it. So Pro Gold Aerostar on any of the plugs, and if you don't fix it because the fault is still there, you put the master on and the needle goes downwards. That's a short in here. 99.9% of the time. Pro Gold is some sort of chemical contact enhancer. I don't know what's in the aerosol. It's a contact enhancer that it says right on the very phrase. It's an electric contact enhancer, and that's why I guess why they call it Pro Gold, and I can tell you it works. It puts some chemical treatment on the surface of the pins in the plugs. So after you've shaken it off, it leaves something there, and you put the plug together, and the connection's perfect. And you haven't had to worry, like Jimmy does, about going in there with a little tool and cleaning pins. Just spray the thing and it's done. That's the same thing. It's Pro Gold. It's made by Deoxit and it's called Pro Gold. Sandy, you're right. It's the same stuff. It's the same Aerostar. I don't know what they use it for, but you get it in instrument shops. So you go flying and you get airborne and you go to raise the gear and it doesn't move because the safety bar is in the way. The most likely problem is, believe it or not, your nose strut hasn't fully extended and therefore it's not hitting the squat switch. So everyone immediately goes and lubricates the squat switch, but most of the time that's not the problem. Most of the time the problem is the nose wheel, as it extends, has bound, because remember it has to turn to come back and fully extend. It won't extend if it's still on an angle. It has to be perfectly straight to fully extend. So in the Aerostar, as it's extending, it's turning to come straight. If it can't turn, it won't fully extend. And if it doesn't fully extend, it doesn't hit the squat switch. And if it doesn't hit the squat switch, the safety bar doesn't move out of the way. An easy way of finding it with your shops, wherever you are, is to put a tow bar on the airplane and turn the nose wheel off center, and then just pull the tail down and watch the nose wheel. It should turn as it's extended. 99% of the time, it sits where you left it. So that's why the safety bar doesn't move, because the system thinks you're still on the ground, so it's not going to retract the gear. If you try and override it, you push the bar out of the way and lift the gear, and there you get the horn. So circuit breaker row, top row, right-hand circuit breaker right at the end says gear warning. You end up pulling it. The trouble is that's also part of the pressurization. So now, if if you put it in prematurely, you get the gear horn. So the easiest thing is to make sure that the gear is working so that when they pull down, it turns straight and extends. And it may just be a stiff nose gear scissor. Lubricating it may be all it needs. It can be, but you're going to... Yes, but you're going to see that when you do a pre-flight from the nose strut being low, because the nose strut air pressure is really low anyway. Just pick another picture. Any questions or anything? Anything else? So I didn't come up with any program other than these, so we can just pick these pictures. So when Joel talks about changing the wiring in the Aerostar, this is what he's thinking about. Joel, with all due respect, I don't want to change that. So nose gear steering switch, we talked about that. The upper half does left and right, the bottom half does the return and the grounds for left and right. So there's the pin on a Weeble gear when that nose gear strut extends in the center. That pin is what gets pushed. That's what that one looks like from the back. The ozone one has got the pin protruding on the side. It looks like a rusty nail. See the little ammeter there? That little ammeter on the left is the prop de-ice ammeter. Next picture. The prop de-ice ammeter, all of these ammeters want to know how much current is going through the wire. And prop de-ice, just like the main wiring, is pretty heavy wire. And you can't attach the heavy wire to these little rinky-dink gauges. So some smart person found out if you take 2 blocks of brass and bolt a skinny little piece of metal between them that's got a known resistance, you can connect the heavy wire to either end of the blocks, so the wire can go through and connect little wires from the gauge to the top of it, so they only read what's going through the shunt. The main wire continues going through all of it. And if the shunt, as Joel said, gets corroded or dirty, then the meter doesn't work right. So what you see on the system ammeter is exactly the same as the de-ice ammeter. Where is the circuit breaker for your aux hydraulic switch? You want to pull the circuit breaker, of course you've got a problem. Where's the circuit breaker? Circuit breaker. Who knows where the circuit breaker is? You don't count. Who else knows where's the circuit breaker for the aux hydraulic system? Yeah, there is. There absolutely is. See the switch there? Keep going to the next picture. That's the top of the switch. See, it says 5. The switch is the circuit breaker. How many times have we all turned that switch on and off and no one's noticed that's your circuit breaker? So if you get a short in the system up to it, that should turn itself off. Next picture. Next picture. That is the Dorset, that's the wing. We've done that. Next. Next. So, Joel mentioned to you before about the main circuit breakers cracking, the 3 breakers that are rated at 70 amps. They crack because they got tiny, tiny, tiny little screw terminals and they got this big fat wire attached to it. So if you touch that big fat wire and anyone's behind the panel, you've just broken one of those breakers. And like Joel said, they're a nightmare to change. Anything in that area is a nightmare. Next. Next. So this is the pump. That's the electric door seal pump for the Christie option. How many people have vacuum gauge pips that you start one engine and both pips vanish? Okay, how many people have a problem they start the engine and no pips vanish? if you can see it right at the very top of the picture on the right side, you can just see the left edge of a brass-colored tube, maybe in the next picture. No, there is a manifold. It's the back of the cabin on the port side. That's the hose coming to it from the right engine. It goes into the end of this manifold. The very end of that manifold, right where the light is, there's like a cow's tongue hanging down. It's a little flap. And the air that comes in from the hose in this picture pushes the flap open and goes into the center area of this manifold. There's another flap at the other end from the left side. So over time, these little rubber flaps get hard and become brittle, and they stay open instead of closing. So now air that comes in from one side goes through the manifold and out the other side. And the reason they segregate the ends with these little rubber flaps is that end cap has got tubes underneath it that come to the red pips. And that's all they do. So the air that comes into the right-hand side good service, I like this. So this is the manifold valve. So the air comes into the end and goes into this little section that's at the end. And the rubber flap is hanging here. So the air comes in, pushes the flap open, and the air can come into this middle area. If the flap this side is not totally closed, the air that's coming into the middle goes back out of this side. The problem is these little pips at either end, they only go to the red pips on the gauge. And it's pressure that retracts the pip. So if you start the right engine and both pips vanish, it means air from this side is getting to this side, which means that this flap here is no good. And these are repairable. If air from this side, you start the left engine first and both pips vanish, it means air's coming in through here as it should, and this flap is not closing. So air is coming out of here and here, and both pips vanish. The problem with this is it means that your air from the left engine is also coming through here to the right engine. And if there's any dirt in the line, it can go back through the air pump, and now you start the left engine and you take out the right pump. As crazy as it sounds. These two, the small one comes down to the instruments and the big one comes down to the de-ice boots. Yeah, on any of the airplanes that standard equipment have got the air-driven instruments, this can cause, it can really ruin your day. And it's fixable. Okay, next. And next. Next. Go back one. This is the back of the prop de-ice ammeter. See the big wires that got yellow crimps? If these two wires were connected to the little rinky-dink terminals on the back of the ammeter, it would just wreck it. So that's the quote, the shunt that is in between the wire, between those yellow tipped wires. And there's little baby wires from that shunt continue onto the meter, but that's what it's like behind the panel. And that is a shunt. mean this? You mean to get it repaired? I don't think you can get the parts for it. I know Tempest Aero Accessories can fix this, but I don't think you can get the parts for it. No. Okay, next picture. Prop sync. Anyone have prop sync problems? So, two types of prop sync. Well, there's actually three types of prop sync, but the ones that you're normally used to are either the little switches and on and an off, or the little switches off, on, sync, 3 position. So the latest version, the switch is off and on. And this is the right engine governor. And this block on the end that the light is on is the coil for the governor. And with the system working, when you put the aircraft master switch on, even if the prop sync is in the off position, there is power going to that coil. And the power that goes to the coil is half of the system voltage. And inside that coil there's a plunger that is part of the governor, and it moves the plunger in and out of the coil. And when you put the master switch on and the coil gets half power, it moves the plunger backwards and forwards until the plunger is midway in the coil. So the plunger can move into the governor or out from the governor. And when the prop sync is working, all it's doing is the coil is being powered more or less to push that rod in further, or not push it in so far to change the RPM. If the coil is no good, obviously the prop sync doesn't work. And if the prop sync doesn't work, you'll notice on takeoff, your RPM is 50 RPM different from what it should be. On the right engine only. It will be 50 RPM down, and that means that that coil is not working. And it could be because the computer is not telling it to work, or it could be because there's a short in the wire. The normal thing that fails is the wires that come out of the end of that have got a tie round them. They sneak along the inside of the baffle on the left side, and the wires are old, like Joel said about old Aerostar wires. The old wires are old, and they run along the top of the cylinder heads, and they get cracked and they get brittle and they short. And when they short, now they take out the computer, which is repairable by Hartzell, but they take the computer out. The system before this, that has the 3-position switch, operates the same with a coil, but when you move it to the off position, it takes all voltage from the entire system. So now after the engine's running, if you want to use the prop sync, you have to move that switch to the on position. Yeah, off, manual and on. You have to move it to the middle position for the plunger to find its neutral position. If the switch is in the off, the system is tone dead, it just won't work. And the coil is only on the right engine. The older system, pickups in the engine compartment, uses a thing like a flying saucer with little neon lamps, and a big box in the back of the fuselage on the bottom, 176 panel on the left side, and a unit in the right side that makes the lamps flash, and it counts the flashing from the lamps. That's got a thing like a pizza slice spinning around, covering and uncovering the neon lights. The newer system's got magnetic pickups in each nacelle. And so that you know, it's not prop sync, it's not a synchronizer, it's a synchrophaser. Did you know that? So when you time the prop sync, you time it so that each engine prop is in a certain position. So from the pilot seat, that's how you want the blades to pass the fuselage. If you don't time it and the blades do this on the fuselage, they beat the fuselage and makes the whole airplane drone and vibrate. If you got it so the blades pass the fuselage like this, separate times, you don't have that beating and that droning. But it has to be timed when you set the pickups up by the tack drive cable which connects to it in the back of the nacelle. You turn the units before you connect it to the tack cable. That's the only way of timing it. So if the engine, yes, right. So if you've got the engine out and that cable's been turned for any reason, or you've got the tack generator out, or you change the tack drive cable and you turn it around for it to slide in its little slots, the timing's gone. Your synchronizing will still work. You'll hear the droning goes and becomes a constant drone, which means it's working, but the phasing is not working. Now you get that beating through the fuselage and it makes the airplane vibrate, and it will go right through the airplane. If you don't want your turbo mounts to break, you want the smallest vibration going through that airplane. So a working prop sync that's timed, that doesn't make the engine vibrate any more than they already are, helps the turbo mounts. When you pull the prop controls back, can you just go back one picture again? The pear-shaped lever on the top is where the push-pull rod is connected from your prop control. So when you pull the prop control back into feather, it takes that lever and moves it all the way to the left. There's two holes in the end of that pear-shaped arm normally. There's one right on the very outside and there's one further inboard. And both engines need to be in the same hole. 602Ps are supposed to be in the inboard hole, but if you find that your engine's one side is slower to feather than the other one, you could move it from the outside to the inboard hole. And you just have to reset the position so that full RPM your controls are aligned. If you come down to the bottom of that pear-shaped arm, you can just see the circled end of a spring. So if your control breaks for any reason, that spring will flip that lever around against the high-pitched stop. So a failure of a prop control will give you high RPM, takeoff RPM. When you pull that around into the feather position, it's dumping the oil that's inside the propeller hub, forward of the center hub, behind the piston that's in that nose dome that protrudes forward. It dumps that oil in there that's pushing the piston forward to give you your RPM. So with the air pressure out of there, the prop will want to go into feather position. And it dumps the oil out of the center rod that's in the prop hub back to the engine. So that's when that pear-shaped arm, as you're looking at it, moves fully clockwise. Next position. So Joel was talking about alternators, and there you can see the idler at the top, engine air conditioner on the left, and the alternator pulley in the middle. The belt that's on there, as Joel rightly said, there's been 3 variations of the alternator belt between numbers, and the latest is this serrated 37A19773-382 that, as Joel said, is fatter than they used to be. And no one tells you or gives you a reason why they suddenly make the V shape wider. So now when it goes around the engine pulley that's inboard of that, the belt sits higher in the pulley, and as he rightly says, you can't get the damn thing on except with a tire lever, and you know it's going to break. When we have the ring gear off for any reason, we've actually been machining the ring gear about a 32nd of an inch wider. Now the belt lays flat on the top. End of problem for any time it goes on. Joel's way of playing with a pulley does exactly the same thing. But you have to change that one. You can't change that bottom one, is a marking one, to drive the compressor. So you can't machine that one because it's got the cutouts around it. And as he rightly said, that's the problem with the new belts. The belt before this, which was a 74519, if you can find it, fits perfectly, but you can't find it. Okay, next picture. Okay, go back one picture. So that little belt that goes between the compressor and the alternator, it's a really odd size. It's like a 22.75 inches length. You can find a 23-inch length, and you can find a 22. You can't find the 22.5s anymore because for some reason our friends in China stopped making it. So now to fix the problem, you have to make the V shape of the alternator, which has got a pulley and a half a pulley. The part you can see is the face of it, which has got the two locating holes, and then there's another V behind it. The main alternator belt runs inside, and as you move further backwards, if you were to be holding the pulley is just half of the V. It's not a whole V, it's half the V, so it's an angled back. And then separate from that, there's a disc that has an angle on the front of it. So when you assemble the two parts together, you're looking at what looks like a double pulley. Except the back half is separate from the front half. So that means you can add shims in between the parts and make the V narrower and wider. So as crazy as it sounds, your maintenance shop has to pull all this back together with a belt to find out if it's the right tension. If it isn't, they've got to drop the alternator down to get the pulley off because it doesn't clear the ring gear. As you can see, it's right behind the teeth. You've got to drop the alternator down, undo the nut, take the front off, add a washer in that space, put it all back together, get the belt back on to find out if it was any good. No, now it's too tight. So you do it all again, and you play about with this for 4 hours to get the belt tension right, because it should be 22 and a half, and you can't find one. You can have 22 or 23s. We put washers in there. We put in there whatever it takes to get the belt tension right, because once that's all tightened down, it can't move. Well, if there is a misalignment, there's two things you have to make sure. You have to make sure that this big pulley here and the idler above it and the engine ring gear all align, so that when you stand beside it, you see one straight belt. You can't have a belt that does this, because if the belt's on an angle, the belt rides off and the belt will break. So this pulley that you're looking at, you can actually move it backwards and forwards on the shaft by taking the pulley and any shims that are behind it, and the back half of the pulley you take off, and then you can add a shim behind it. So you can move the whole assembly backwards and forwards for alignment. So again, you're playing with the alignment, you're playing with the drive belt for the air conditioner, and you can spend 4 hours doing this. And you just have to put down on your bill, change the air conditioning belt. How could it take 4 hours? Okay. Next picture. So Joel was talking about the electric system. In the bottom right, that's the two standard regulators. Bottom left is two heat sink fins where your main isolation diodes are. Above that is the two little black over voltage regulators. Middle on the right hand side, that block you can see to the right, yeah, that's it. That's the unit that turns on the warning light for the alternators. That is connected to a center tap of the alternator windings, and it senses half the alternator voltage. So if the alternator is giving out 24 volts, that wire will have 12 volts. And since that wire coming off the back of the alternator is a hot wire, it has to be protected. So now there's a fuse in the wire, and that fuse in the wire hangs down behind the alternator. And very often when that warning light left alternator or right alternator turns on, it means either the wire to the fuse is broken or there's oil in the fuse holder. And you undo the fuse holder, flush it out, put it back together, and you fix the problem. And that's the unit that gets the voltage from the alternator. So again, that's the picture of the ammeter fuses below the circuit breaker panel. Next time you get in your Aerostar, you should look across the seat underneath and see it. You've all got them. So that's the wiring on the back of the alternator. Those little wires, they're the wires that go to the brushes. 90% of the time when the alternator doesn't work is because one of the field wires, those little wires, has broken off. If you land somewhere and you find a local shock, can you look at my alternator? You've proved it's not working, because 40 amps in the middle, 40 amps on one side and nothing on the other, so you know it's real. And you say to the guy, could you look at the alternator? All mechanics, me included, the first thing you do is you go to the alternator and you check for voltage at the field wire. And except for 700Ps, or ones that Joel's modified, there's no voltage there. Because the voltage comes from before the diode, so there's nothing coming back from the aircraft to the alternator. So the first thing the mechanics will say, there's no voltage here, the regulator's no good, which is not the case. That's a close-up, that's the little wires, the two field wires up the top. That terminal right at the bottom is the aux terminal, half voltage, that goes to the warning light. And that's the main one at the top, that's the main output wire. On the left, that grey box with screw thread sticking out, on top of there is an alternator fuse, but they call it a current limiter. It is two flat Paxilin units with a flat piece of metal between them, which is a fuse. It's an 80 amp fuse basically. And with vibration and heat, sometimes those Paxilin blocks on the end get loose and they wiggle about and you lose the connection. So now the alternator warning light is not illuminated because the wire is still coming out of the aux terminal, but there's nothing on the ammeter because the fuse is separated and there's no power getting back to the airplane. But the warning light is not on. So the only way you know from this is looking at the ammeter. So in flight it does you no harm occasionally to check the readings of the ammeter. Because if it's in the middle position, you won't know there's a problem. And the light is not on, so you won't know there's a problem unless intermittently you reach over and select and check left and right. That's the close-up. The current limiter is right on top of that box. Also on top of that box is a noise suppressor. So you have whining through your headphones. Worse with Garmin radios. The noise suppressor right on top of that can be the problem. If the noise suppressor, which is like a condenser, has got old and weak, it doesn't smooth out the voltage ripples, which it should. So now you end up with this, and there you get, that's what you pick up in the headsets. Back panel again. That's a close-up of the main system isolation diodes. The power comes in on the back side of there, and it comes out this side. And that's in the bottom left corner when you're kneeling down on the bench seat looking to the left. Yeah. That's the two sensors on the left, telling you whether the alternator light is going to turn on or not. And again, if you see the light, don't assume it's true. Voltage regulators have got 4 terminals. A field, a bus, a ground, and a parallel, PAR. If you get a funky problem with paralleling, if you take that PAR wire off, you separate the systems. Now they're not talking to each other. The PAR wire just goes from one terminal on one, hops over to the other regulators of the same terminal, and it tells the regulators, hey buddy, what are you doing? I'm high, get down a bit. So it makes the regulators try and bring the system together. If you want to know where's the fault, just take that wire off. You can fly with it off. Now you've got 2 separate systems that are not talking to each other. Most of the airplanes have got a fuse in this panel, center back slightly towards the left, which is the fuses for the field fuses for the regulators. Next picture, yeah. There's the 3 output circuit breakers. Again, tiny little rinky-dink breakers with humongous wires screwed to the back. Really not unusual for them to crack. if someone's got to get up there and change them, it's a nightmare. As Joel said, anything behind this panel is a nightmare. Joel wants to change circuit breakers. God bless you. Yeah, that's right. The young one. Crawl up behind the panel.
And I don't know how many planes, like I don't have those. I have the, I don't know, 70, yeah. I have a relay.
A relay on the regulator system.
I don't have these circuit breakers.
Oh, so you've got the relays in the back of the cabin.
Yeah, and the 176.
Right, which is where the really old airplanes started, to confuse people like myself and Joel and Don, how it all works. Top right hand corner you see a radio master switch. Anyone know what that's for? So buried behind the co-pilot's panel, against the side wall, high up behind the upholstery, where even pygmies can't get to, there's a relay and a fuse beside it. It's a 30 amp fuse. And sometimes with age the fuse trips, and now you put your avionics master on and the whole avionics panel's dead. And when that happens, it's the fuse has gone. And now you need to find a midget pygmy to get up behind the co-pilot's panel to get to that fuse that he says, quote, is not there, I can't find it, to change the fuse. When that happens, you have the ability to lift the guard of that red dangerous looking switch and flick the switch back on, and that puts alternate power to the radio system. The problem is there's no protection for that switch. So if you've got a big short, when you flick that on, the big short's going to get worse. Okay, next. So that one says left and right field. So right now the only ones that have field circuit breakers are the 700Ps, factory 700Ps. They'll also have power at the alternator field. Okay. If you lose the left alternator and you think there's a chance maybe you've broken a belt, if you reach through the right side of the cowling, or as you're facing it, the left side, and bring your fingers forward, you can, with your fingertips, you can feel the belt. So if the belt's there, you'll feel it. So you don't have to take the cowlings off to find out if the belt's broken. You can feel it. And you can feel if it's hard, meaning it's under tension, or if it's soft or not there. And that's without doing anything, without taking the cowlings off. No, don't do it with the engines running. Okay.
That's the last one.
Okay. That's my sleeping presentation. If you have any questions on anything. Thank you. I'm just intrigued, did anyone bother to write down the part numbers I gave you for the Weevil shear pin for the door? Does anyone have one in the back of their seat? All those of you that put your hands up that you have are the only ones that are going to smile when your nose doors are drooping. Everyone else is going to be very unhappy and wish we had a shear pin in the back of the seat. For the ozone, this was an NAS 464 P4-43. If you can't find it, you could get an AN4-43 bolt, which is not close tolerance, but it will still work. If you've got a paralleling problem that you can't work out what's going on, especially if it changes, take that PAR wire off and leave it off and fly with it off, so now the systems are not talking to each other. And now you'll find out which system can do it, because if one's going up and down, it will make the other one go up and down. And you can fly with it off. Thank you.